concept is lateral shift. Here we are going to consider refraction of light through a glass slab. It is having the thickness T. When light ray passes through a parallel sided glass slab, it undergoes refraction at two parallel sides and emerges out. So the direction of emergent ray is same as the incident ray here. But the path of the emergent ray is shifted laterally by certain distance as we have shown in this figure. Here we can observe clearly the ray of light. It is going to enter into the glass slab where AB will be the incident ray here and the BC will be the refracted ray and CD will be the emergent ray. Where the incident ray of light, that is AB, it is laterally shifted along BE, which is represented by LS, that is the lateral shift we can see. And here in the diagram, T represents the thickness of this glass slab, R represents the angle of refraction, I represents the angle of incidence. Okay. So definition of lateral shift, here the distance perpendicular between the incident ray extended and the emergent ray is called lateral shift. It is given by the mathematical form lateral shift. LS is equal to T sine I minus R divided by cos R, where T is the thickness and sine of angle of incidence minus refraction I minus R. Cos of R means it is angle of refraction. Lateral shift is 0 for normal incidence. When normal incidence happens, angle of incidence will be equal to 0 and the angle of refraction will be equal to 0. So we get T sine, substituting the value of I and R in the above equation for lateral shift, 0 minus 0 divided by cos 0, which is obviously equal to 0. As cos 0 is 1 and sin 0 is 0. Into T will be 0. Obviously, we are going to get the lateral shift is 0 for normal incidence. So lateral shift is maximum for grazing incidence. For grazing incidence means angle of incidence will be equal to 90 degree. When we substitute the angle of incidence is equal to 90 degree, we get 90 minus R. Sin 90 minus R is cos R. So T cos R divided by cos R. Both cos R and cos R, they get cancelled. Remaining is T. So here